How do you use a TS diagram to analyze the Rankine cycle? Imagine you're looking at a graph that shows how temperature and entropy change during a steam power plant's operation. That graph is called a temperature-entropy diagram, or TS diagram. It's a powerful tool to understand how the Rankine cycle works. The cycle involves four main steps, and each one shows up as a specific line or curve on the diagram. First, water is compressed in a pump from low to high pressure. On the TS diagram, this appears as a straight vertical line moving upward because the entropy stays the same while temperature increases slightly. Next, the water enters the boiler where it is heated at constant pressure until it becomes superheated steam. On the diagram, this is a curve that moves right and upward, indicating both temperature and entropy are rising. Then, the steam expands through a turbine, producing work. This process shows as a vertical downward line on the diagram, meaning entropy remains constant while temperature drops. Finally, the steam condenses back into water in the condenser at constant pressure, which appears as a curve moving left and downward, showing decreasing temperature and entropy. The TS diagram also includes saturation lines that separate liquid, vapor, and mixed phases. The cycle path crosses these lines at key points: when water boils, when vapor becomes superheated, and during condensation. To analyze the cycle, you use steam tables or Mollier charts to find enthalpy values at each point. These values help calculate work done by the turbine, work input to the pump, heat added in the boiler, and heat rejected in the condenser. For example, the work from the turbine equals the difference in enthalpy between the turbine inlet and outlet points. The cycle's efficiency is then calculated by taking the net work output divided by the heat added in the boiler. This shows how well the cycle converts heat into useful work. When real systems are considered, irreversibilities like friction cause entropy to increase during compression and expansion. On the TS diagram, these effects make the lines slant, showing entropy generation. Engineers use this visual to identify where performance losses happen and how to improve efficiency. The TS diagram helps in designing better power plants by choosing optimal pressures and temperatures, deciding on superheating levels, or adding reheating and regeneration stages. It makes the thermodynamic principles clear by visually showing how temperature and entropy change at each step, making complex concepts easier to grasp.